Well, thank you very much for inviting me here. What we're going to be talking about today is e-waste, electronic waste. And
The closer you are to your computer, the better the recording will be of your voice.
oh, so I need to be here.
It'd be probably better for the Zoom recording.
My style is to wander around.
Okay.
But I'll sit down so that I can get it on.
Or carry it with you.
I'll carry it with me. So e-waste, you're probably familiar with, and we'll talk a little bit more about specifically what it is and what maybe it isn't. But I think it's important to talk about the origin story. We've been working on this for about, since 2021 is when it actually, the origin. And it started with a professor at Macalester College named Rupali Patki. And she did a study, and she was on sabbatical, and her study, for stepping back, her area of expertise is mining industry.
Oh.
And so she was doing a study trying to determine how mining met the need for the materials that go into electronics. And as you're all very aware, our world is getting to be more and more dependent on electronics. But the amount of material that goes into the electronics, excuse me, is increasing. They're getting to be more complex and requiring more and more of the critical metals that are in short supply. And so what she wanted to find out was, could we get enough material for a foreseeable future to meet our needs for the materials that's required to build all the electronics that we're anticipating to need. And so as she did the study, what she quickly determined was that mining by itself and or e-waste reuse by itself, neither one would be sufficient. It's an and situation going forward. We're going to continue to need to mine, hopefully responsibly, but we're going to continue to need materials from mining. Plus, we need the material that is being used or has been used to be recovered and reused. Now, what is in electronics, the critical metals, you cannot destroy a critical metal. They're elements. Elements are stable. You can smash them and do whatever you want, but ultimately, when you get down to an atom of gold, it will always be an atom of gold. You can't destroy it, but you can lose it.
Mm-hmm.
You can go out and throw it out in the field, low concentration, you'll never find it again. And that's what we're doing right now with 3/4 of our material. In Minnesota, for example, we collect about 23% of electronic waste. And unfortunately, we're not particularly good at it. So while we're collecting that, we're not doing very well at collecting the critical metals. So we'll get into more detail about that. So anyway, in 2021, she presented a report to a meeting of the IRPS, Iron Range Partnership for Sustainability in Virginia. And Marlise Riffel was the chair of that group at that time. And she noted that this was something that had potential to also be valuable for jobs as well as recovering the materials for reuse for meeting our electronics needs. And so she actually approached me. I was a candidate for senator briefly at that time. She approached me and said, isn't there just an opportunity for jobs? And so that started the question, well, I wonder what the opportunity is. And we tried to figure out by looking up research what the opportunity for jobs would be. And guess what? There was no information for Minnesota, United States, the world, none. There was no information. So we said, well, I guess that's the first thing we're going to have to do. So we sat down and over a period of about probably about nine to 10 months, we collected the information. Marlise looked it up. I put it into big spreadsheets. We got a couple of people to help us. Rupali helped us a little bit, and we hired on Maria Jensen from Repowered, which is a recycler electronics recovery business in St. Paul. And from that, we created the first report. Now, if you go to the internet right now and you ask about a recovery of recycling e-waste, our report will be one of the first things that comes up. So it's kind of startling because our report's being used all over the world now because it's the only one available. There is no other research in this. And so from this, we used information that was available, collected it into the report. And we found out that, actually, I'm getting into the paper here, but I might have to start to put a presentation. We found that there was about $3 billion worth of e-waste wasted in Minnesota each year,
You mean that would be value if you could get it out?
if you could get it out. And what's interesting is, as I mentioned earlier, a lot of what we're collecting now, actually, it's not the high value stuff. We're collecting more like old TVs rather than
Even on
current
solder.
computers. Yeah, yeah, solder is about it. So we'll go ahead and start the presentation here. So let's talk about what is e-waste. And so this is one definition. It's pretty handy. It's simple enough that you can get your head around it. So items with a cord, with a battery or circuit board that have reached their end of their useful life, as small as a vape or as large as an industrial heat pump or anything that you might see on a commercial, big transformers, anything that's no longer serving a useful purpose and is being discarded or potentially discarded, no longer being used in it for its original purpose, that's electronic waste. Now, you see cords there, batteries in the middle are particularly a problem because they're also toxic, and we're going to talk a little bit more about some of the other hazards about them. And I like this picture on the right because that's a land crab in Indonesia. One of the huge problems with electronic waste is you go to the dump with most of your e-waste. And even people who don't want to do that have a hard time properly disposing of electronic waste. And so if you talk to the people that work at the sanitary landfill in St. Louis County, they will quickly tell you they would love to have more laws in place, more processes in place to recover this material. And why is that important to them? There's a couple things. Says right now, we as taxpayers are subsidizing the electronic waste that's being tossed. Either it's being polluting our waters or it's going into a dump. If it goes into a sanitary landfill, it takes up space. It creates toxic problems for the employees. And batteries, particularly lithium batteries, are dangerous. They explode. And it's very common to see actually literally garbage trucks in metro areas exploding in flames from lithium fires. And as another example, we talked to a lady from Rice County, which is Faribault, and they had a fire in their fast landfill. It was caused by a battery. And the fire burned for 2 weeks. And she said for 2 weeks, basically, she could not go outside because she was 2 miles downwind. It was so toxic, she would choke and it would cause her eyes to water. It was unhealthy. It burned a hole in 2 weeks that was the size of a football field, 30 feet deep in the landfill. And if you talk to landfill workers, they say they have small fires almost every week. If you go to like St. Louis County landfill, they'll have probably that week, they'll probably have a fire. And that's going on all across the state. So you're losing, you're taking up space in the landfill, but something that could be reused. You're at risk of causing fires and your toxins and pollutions. And oh, by the way, it's worth $3 billion. So there's a lot of reasons why you might not want to throw it in the dump. Let's see here. Next. Okay, so most electronic waste has its value in a few elements. There's the report that we did, we identified 68 elements that were in electronic waste. Many of those elements are not particularly valuable, but there's a handful of them that are extraordinarily valuable. The top one, gold. Not a surprise. There's a lot of gold, a lot of silver, a lot of copper, a lot of platinum, a lot of palladium. Those are the big five. Most of the value in electronics is in those items. Now, there's still a tremendous amount of iron. There's a tremendous amount of aluminum. So if you look at it from a weight perspective, that's where the weight is in things like iron and aluminum, and of course the copper. Copper is actually, interestingly, copper. I'm going to just summarize, go to the end here. So copper today, if you go to copper mines and you're mining copper ore, the density of copper in that ore, I can't remember the exact numbers, but I'm just going to say it's 100 times less than what it used to be. the concentration of copper is dramatically getting less and less. And we use a tremendous amount of it, and it's critical. Almost everything's built on copper. And so this is getting to be a real problem, and the price and value of copper is going up such that something that we think of as common and cheap and expensive is the fourth most valuable element in e-waste. So from a value point of view, it has already climbed the ladder. Okay, so if I bring you 100 pounds of electronic waste and I grind it up, and then I take out all the different elements that are in it and different material, the elements in it constitute about 30% of the material. The rest of the material in e-waste is things like plastics, fiberglass, different kinds of plastics. Actually, the second most common, after I think by weight, I think iron is the most heaviest item, but in terms of volume, plastics. Now, plastics are interesting because right now what happens with plastics in e-waste, one of two things happens generally. Either it goes into the landfill, or if it happens to be shred with printed circuit boards and it goes to be recovered, the current state of the art is to take it to smelters. Now, in North America, there's one big smelters at Sudbury. If you look at an aerial picture of Sudbury, 30 miles around Sudbury, it looks like a desert. There's a reason that there's not a lot of smelters. The United States has one in Georgia. It's called Arubis. I'm sorry, Arubis. And it's a new one, and they're trying to do it smelting in an environmentally sound way. It's really hard because what is smelting? Very high degrees. They bring it up to 2,000 degrees and they burn off the plastics, for example. To smelt, they also add, I think it's carbon carbonate or something like that. You don't quote me on the element, but they add material to make the. So, where was I? Oh, so the smelting process is very dirty, burns off many of the materials. Literally, of the 68 elements they could collect, at that point, they're focused on getting 5 of them. The rest of them are either discarded, not captured, whatever. They aren't being reused. So smelters are dirty. They run at high temperatures, and they're offshore because the United States has laws that make them impractical to operate here and meet the air quality standards. And so they go offshore. And then there's another story about offshore is a lot of times it doesn't go to a reputable offshore smelter. I worked in Shanghai for a while. And in Shanghai, you could walk down the streets and you'd see children tearing apart electronics, and they'd be pulling off the aluminum and they'd pull off the copper and they'd pull off whatever they could get to resell. I can swear to you that those children were not safe doing that. They're being exposed to many toxins. And that was very common in Shanghai. And Shanghai is not a particularly bad city. If you went to cities in Malaysia, I believe it's the worst country in the world right now. People are dying from recycling, and they can't keep up with the material. Best Buy ships a lot of their recovered. You can go to Best Buy and drop off used electronics. When you drop it off, they're supposed to handle it responsibly. Well, some of those shipments turned up in Malaysia, which is the worst place in the world. And people are dying over there from our wastes. So if you don't feel any social responsibility to this, I think we should. So that's another factor. And that's reason that smelters are not in the United States is that they're not safe. And I guess I'll put it this way, I don't know of a safe smelter anywhere in the world. They all are characteristic burning off these materials. Okay. What else I got here? Yeah, we know they're essential. Yeah, okay, we're gonna go on. Oops.
I have to click.
There
we go. Let's
down here.
click down there.
Oh, okay. So, so the study results, and we'll just go to the bottom ribbon here. So the population of Minnesota is just under 6 million. Each person in Minnesota creates, on average, a year, 46 pounds. Now, you're saying, well, that can't be true. I only have a little pile I take to the dump, once a year or whatever. Well, what about the hospital that you go to or the business that has laptops and they go through a new generation and throw out the old computers and bring in new laptops? So they got new medical equipment, all that old equipment from businesses, from schools. Think of all the laptops that kids have. Those get recycled. We hope they get recycled. Turns out that not all of them do, but actually businesses, schools, hospitals are actually pretty good because they often contract with collectors. A collector is someone that usually pays them a small amount, comes and gets it, and then responsibly depopulates the boards, takes off the transformers, takes off the heat sinks, and eventually gets down to a bare board. And then the collectors will then shred those boards. And so now you have printed circuit board, shredded material, and that's what they sell to the smelters. That's the critical material. So when they sell it to the smelters,
Now, the circuit boards are mostly fiber. Why are they getting those into a smelter?
because that's how you have to, I mean, the fiberglass, the plastic in the board, printed circuit board is where the metals are. There's traces that are in the plastic. There's some material on
It just
top.
unlocks a little bits of lead for sure.
Oh, yeah.
It's
And there's a lot of gold and copper in it too.
Okay.
Actually, these big five I mentioned before, they're all in high concentrations in printed circuit. And it goes to the smelters, and of all the elements that are in there, they only get the five. The rest of burned off. So all that the green board, as you think of it,
Yeah.
that's all burned.
Oh, yeah.
All the plastics are. Yeah, no, I think there's more to that story. So we create about 266 million pounds of e-waste in Minnesota a year.
Ask a dumb question. There's got to be sort of a line between a telephone and a refrigerator. They both would be e-waste by,
Correct.
I think, right?
Yep. And a good point. Like white goods as like a refrigerator or I don't know, dryer, washing machine. Actually, those get processed fairly well. They get collected at the dumps. If you go to a dump, you'll see they'll have them stacked over there. So if you take it there, they actually are processing those fairly well. The problem is what's in there are very simple and generally not a lot of critical metals, like almost very, very low levels. So they're getting processed. But if there's a printed circuit board in there, that printed circuit board is being lost at this point. What they're after is the aluminum and steel, primarily copper. Those are the three things that white goods have a lot of. Like you have the big motor, battery windings. Yeah, of course. So good comment. And so what I'm focusing on is the high value electronics that is in short supply, which includes copper. So the fact that they're recycling, that's really good because there's a lot of it is recovered from the white goods. So there's the $3 billion of value there. That's how much we produce in Minnesota, $3 billion worth of critical metals. And if we were to process this all properly, it would result in about 3,300 jobs, both direct and indirect jobs.
So how would you propose processing it rather than smelting it?
That's what we're going to get to. Did I give you a list or something? Anyway, so we're going to focus on where the critical metals flow because this is where the value is, and that's where our business is based on. So I'll get into more detail of that. So we're going to discard the white goods, and there's another area that I'm also discarding. It turns out to construction. You wouldn't think so, but construction creates a lot of waste material. And oddly, construction folks are actually pretty good at recovering it and recycling it. So most of the folks in construction realize that copper has a lot of value.
Oh, yeah.
And so they're gonna, sell it, recover it and sell it when they can.
But you wouldn't.
No. Yeah. That's one of the reasons I'm not talking about it, because they're doing a good job and there's not a lot of economic opportunity there. So at the upper picture, these are both pictures of printed circuit boards after shred. Shred is the key concept here. So you take a printed circuit board, a nice flat thing with all kinds of electronic traces on it in it. You grind it up, break it up into small items. Typical size of the shred is a quarter. So once it's shred, so I'm going to use a company in St. Cloud called IRT. It's now owned by Paladin. They shred boards, just like I said here. They load it into a truck. They drive it to Chicago, put it on a train, send it to the West Coast, put it on a boat in containers, and theirs goes to Korea, I believe. And that's where the smelter is for theirs. And so I'm going to get into more detail about that later. But that's what collectors do. They're the ones that buy it from you or take it from you or from a business. They're the ones that depopulate it. They're the ones that grind it up and then they load it up and ship it. So that's what a collector does. The second role is that of the refiner. The refiner in this case is a smelter. Now you can do refining of the materials in different ways, but the standard, I think it says here how much 90% of the shred from the United States is processed overseas. Okay. So there's two ways of processing this currently in the world of significance. There's other ways, but they're hardly ever used. Almost all the material is going to be done one of two ways. It's either going to be done with pyrometallurgy, which is the smelters, or it's going to be done with hydrometallurgy, which is done with chemicals. So you have a choice. At high temperatures, a lot of waste. With smelting, you actually end up with a lot of physical waste. There is piles and piles of this material because they've added calcium carbonate with it. It combines with it. It ends up being waste and it has to be discarded. Hydrometallurgy is actually a little cleaner, but it does use toxic chemicals, but it's usually contained. It's actually, if you're an environmentalist, you would say hydrometallurgy is preferred. Now, it turns out that unfortunately it's not real high capacity. You have to make immense facilities to do hydrometallurgy because it's a chemical process. It takes time. You have to separate things, and it's actually a very complex process, but it is environmentally a little nicer to the environment. But it's not high volume. It won't handle the kinds of the volumes that we need to. Okay, so. Okay, come on. Help. Thank you. So we're going to talk about a new method, but it's not really new, but it's new to the United States. There is a third mechanism, and that's what we're proposing to use, and it's called physical separation. And why I say this is not new, Europe about 15 years ago looked around and said, we need these critical metals too. Oh gosh, we don't have any mines. There's almost no mines in Europe. They have very little sourcing of critical metals within Europe. And they were pretty bright and said, it's in all this e-waste that we have. Why don't we mine it from the e-waste? So 15 years ago, they started passing laws, and every year they continue to ratchet up the legal structure. But 15 years ago, they required first of all, collection. So they had low collection rates like we have now, they used to have, that 20% kind of thing. So now Switzerland's collecting 99% of theirs. Most of the countries in Europe are at 70, 80%. And every year they have to ratchet up because they're required by the EU law to do that. They cannot sell critical metals outside of Europe. If we wanted to go buy their critical metals, they could only sell it to us if they were doing it illegally. The EU does not allow critical metals to leave Europe because they're too precious to them, because they have a shortage. They needed these materials, and so they were having to source it on a global market. So we'll get back to that a little bit later. So Switzerland is a country that they got some pretty good engineers there, and there's several companies there that have been working on this for 15 years. And our little company called Reclaiming Critical Metals, we looked around trying to figure out how could we do it differently. We found out about this physical process. Doesn't use high temperatures, doesn't use chemicals. It simply is just grind it up. That's as simple as it is. It just grind it up. And this company, and there's several companies actually that, and they're all located oddly in Switzerland, that have been working on this for 15 years. And I can give them a printed circuit board. I can either give it to them ground up, or I can give them a whole circuit board. They don't really care. If I give them a whole circuit board, they grind it up and make it like, the shred. If I give them a shred, that saves them a step. But they go through a process of grinding it and pounding it and hammer milling it down into as fine particles as you get. And as they go through this process, at various stages, they pull off like iron, really easy magnets. Some of this material, like plastics, grind it up and blow at it, it's going to fly away, and then they collect it. And so I'm going to jump to the bottom line here. They can take that same printed circuit board and they can recover everything in it, 100% of it, including the plastics. By the way, there's two types of plastics, and so they need to separate the two types of plastics. And so when they get done with it, they basically have what they call as value streams. And so in this value stream, you have maybe the aluminum, and this one they have the iron, and this one they might have a mix of the plastics, and they've got to do some further separation. But first of all, one of the things that they have that's rather remarkable is that they have an airtight air system, air filtration system, because where the most valuable minerals are is when you start grinding this stuff down, you get the gold and the platinum and those metals down literally almost to an atomic level. And where's it end up? It ends up in the air because you're doing a physical process to it. So it's going to become dust. Well, you don't want to lose your dust. That's where all your precious chemicals are. So they have absolute air containment. So there's no air pollution with this either, because you don't want to lose the air, because everything in the air is your most valuable material. So what we're proposing to do is implement this physical system. Now, what you're seeing there is not the equipment we're putting in. It looks like some of the equipment we're putting in. Right now, ours looks like it's going to be what they call units. They have a pre-shredding unit that's similar to that. And then the main unit is what they call Unit 4, and it stands 60 feet high. And it's got all kinds of things in it, because it's got air, magnets, winnowing, weight separations. And so they break out everything mechanically by using different methods. And when they get done, most of the material can be separated and sold directly. Right now, there's about 3 to 4% of it that is still not separated adequately. And that right now still requires a pyrometallurgy or a hydrometallurgy to separate that last 3-4%. So what we are bringing to the table that's new, we happen to have a scientist on our team. There's 4 founders. And I'm one of the founders, and there's 3 others. One of our founders has worked for like Medtronic and 3M and companies like that. She's a scientist. That's her title. She's worked for them developing catheters and I don't know, all this stuff. She has been studying biomimicry. So biomimicry is how you look at how nature does something. How does nature grow a flower? So I'm going to tell you a story about the hunting spider. Minnesota, and you can find these. I find them on my dock once in a while. A hunting spider is common in Minnesota. They live along shores, a lot of times under docks. And what they like to do is they like to stab minnows. They live on minnows as their primary food. Now, stabbing minnows, and you think of, they got a little crusty thing in their thing, they poke a minnow with it. Well, it turns out if you look at what that little thing is that they poke a minnow with, it's made out of 100% zinc. They have developed the ability to separate zinc from the environment, concentrate it in their things, and they stab minnows with it. Yeah. And if you look at them, you don't notice it unless you're looking for it, because it looks so natural, but they're actually zinc. And I could go on, if I could remember them all. There's over 1,500 insects that are known to extract various elements. There's like certain types in Minnesota, certain types of our moss also are extracting zinc and other chemicals and elements. The key thing from our point of view is that nature has found a way, and actually I have seen them this person that we have, the fourth person, she had her own electron scanning microscope. So this person takes science really seriously. She took pictures of it, like down in a micron size. You can see little structures that in this case, it was a plant that created little tubes, and it was actually separating gold. And you see that under the microscope, you could see the gold flakes. And then there, so and they have the ability, this particular plant has the ability to do this with many chemicals. It's not just a certain chemical, it's actually a characteristic that this plant is actually well known for in science for many minerals. So anyway, the key thing is not that it does it, because we're not going to go out and get a bunch of these plants and commercialize that, because it will take how long you have to wait to grow plants.
Look for people.
Yeah, I can't wait for it. And so what you want to do is learn how the plant does it. And so that's what we would mimic, is the how, not the fact that they're doing it. And so she's got some work that she's doing on that. And side story, so we were going to work with the Lawrence Livermore National Lab. We had actually signed up, got a slot to go there and do some work, because we have to do some more, high energy, very small investigation. Trump shut her down. So we were screwed. And we thought, well, I'm done. We can't do this. Well, thank you to Canada. We were talking to the National Accelerator Lab of Canada, in Saskatoon. And when we told them what we're doing, they said, you can come here and you don't have to pay. They're so excited about what they're doing. They're going to pay for us to come there and do the lab work. And we're like, oh, thank God, because we were looking like $30,000, $40,000. And now all of a sudden it's free. So and we're on a small budget, so that's a big deal to us. And so they are super excited, and they have agreed that this is probably patentable, and we're going to own the patent on this when we get it done. So they're excited, because this is the kind of thing they get bonus points for, is doing this kind of work. And of course, we would own the patent, so we're quite excited about the security of having figured this out and being able to commercialize it. We think this is going to be the key to our biomimicry of the extraction process. We're going to learn how, in this particular case, how this one plant, which I'm not going to tell you what it is because that's proprietary, but that plant, we see it doing it. The lab in Canada thinks they have the equipment that will allow us to figure out how that works, and then we're hopefully going to be able to commercialize that.
What's your biggest competitor? Is anybody else trying to crack this nut?
No.
This 5% that's left over?
No, not that we're aware of.
Good luck.
Yeah, we're doing. This has turned into an amazing little science project for us, and we just happen to have the right mix of people to make this work. I can't do what she's doing, but I bring something to the table too. The other members of the founders are bringing something to the table, and together we seem to figure out a lot of stuff. And we have some people helping us, and they're very nice, because in all cases they're doing it for free because we can't afford to pay anybody. But we have a number of people that are helping us as I'll call them consultants. They have expertise that we need from time to time, and they've contributed to the discussion.
We are so proud of you, Keith.
Well,
It's like incredible. Thank you.
Well, thank you. I mean, if this turns out, it's going to be a big deal, but we're going to be, I'll show you what's going to happen when we get this done. If I can make this work. Did it work? Okay. I'm going to, unfortunately, people who are online aren't going to be able to see me, but I'm going to be referring to the diagram that you're seeing there. And we're going to start talking about the value stream, where the money goes, where the value goes, where's it come from, who gets it. And we're going to talk about the way it is now. And the top line is the way it is now. And in one form or another, virtually 100% of the material is going through that model right now. So if you start in the upper left, under the word today's method, you have our home. So you're starting with electronic waste in your home. And I refer to a collector in St. Cloud, that IRT company in St. Cloud. So if somehow your e-waste gets to that collector, either through, literally you can drive up to their door and hand it to them. They'll take it from you at the door on their loading.
I give mine to St. Louis County though, then they take it down there.
No. that you do give them stuff. They only take 4 items down, and I can't remember, one's TVs, one's, yeah, most of what you give them, because this is another whole story about the laws in Minnesota, which need to be upgraded, but I hope there's not a Republican. Republicans keep blocking us. We've tried 4 years now to get the appropriate law through, and they block us every time. Right now, there's one vote if the House changed. We got it through the Senate. One vote, and it's tie in the legislature now, so they have to have, we have to have one more than we have. We're one vote short, and we're stuck. Because what you said is what should be happening, and we have a law ready to go to do exactly what you're saying. And the county wants it to go. Everybody that's involved in this wants it to go because it's the right thing. People have an opportunity to recover more, do the right thing, reduce the toxins in our environment, and make money if we can collect it. And they're blocking the collection right now because what's happening right now by law is only 4 items go from the dump to be processed properly. So thank you for that question. Boy, you really are on right. You're asking the right questions. So right now, that collector will take your e-waste, or somehow I could get there. Like we have a collection event in Virginia every year, and we advertise it, and people are encouraged to bring their stuff in their garage. One guy brought 6 Trinitron TVs. You ever seen 6 Trinitron TVs? It filled the back of his pickup. And for that, he had to pay because there were actually a lot of plastic in and not much value. But anyway, he was so happy to get rid of them. He was happy to pay the $50 because now he could park another car in his garage. So anyway, collection events, however it gets there. So if it gets to the collector, IRT gets 80% of their material from hospitals, schools, like I mentioned before. They'll take that, they'll process it, they'll take off the transformers and so forth, and then they'll shred it. And then they load it into a truck. I left out the rail part here, but it gets eventually to LA port. It's put in container ships, shipped overseas, 70% for pyro, 30% for hydro. In terms of the refining, both of them create waste. Pyro's worse, but there's waste and toxins from the other as well. Then after they've done that, then let's say they're actually, I know IRTs actually does go to Japan. The graph has that correct. Theirs goes to Japan. So the company in Japan, at that point that they've finished refining it, sells it on the international market at international market prices. Gets loaded on the ships. Now it's smaller because when I sent it over, I sent a lot of plastic and stuff. Well, that all got burned off, so that doesn't come back. So the return ship's mostly empty because the amount of material that you can probably hold it in your hands like this from a ton. So anyway, it comes back and then it gets shipped back. And we use Chicago because there's a consumer, Motorola, has a plant in Chicago. They use a lot of this material. And so if we being our company were selling, they'd be a likely candidate for us to sell to. So anyway, we use Chicago Motorola. That takes 14,000 miles, 60 days. And where the value is collected is when that smelting occurs. That's where the step up in value occurs because it goes from a ton to a few pounds. And it goes from a lot of plastic and stuff that's worth nothing to a couple pounds of things that, in fact, so let me step back. So when IRT sells it to a refiner overseas, it sells for something like $3 to $5 a pound. When it gets processed from that ton, they have $40,000 worth of material. And that's not full value. That's only the value at that point because it goes through one more step I don't have up here that it doubles in value. So ultimately, that $2,000 or so times three, $6,000 worth of material that was collected is now worth $80,000. So the value in that shred is $80,000, and for that in that ton. And that company in Japan is the one that gets that step up from the $3 a pound to the $40,000 value. So it goes from $6,000 to $40,000 by doing that smelting. That's offshore. That's jobs offshore. It's, well, fortunately, pollution offshore, but that's not good for the world. And so that's where the value is captured right now. And then they sell it into the market, and then so they get another step up when they sell it into the global market. So they capture the full $80,000 a ton. Okay, so our model down here, we start at the home, goes to IRT, so no change. They shred it just like they do now. So instead of going to, Japan, it goes, 300 miles up to us in Virginia, Hibbing area. We do the refining, but we do it with the physical process, the no pollution, physical only. We get the same markup. It still gets up to that value. Plus, we sell off the plastic. Some of the things that they're burning off or discarding in the waste, we're going to capture all that and we're going to sell all of it. Now, granted, the plastic isn't worth very much. We'll probably at best break even, maybe lose a little on, but we're going to be doing the right thing with it. So when we get done with it, it's sitting, let's say we're in Virginia. So we're sitting in Virginia. So now all of a sudden, but we paid $6,000 for it. We have that, we captured that value. That's a pretty damn big markup. Plus, then we will sell it on the international market. We'll get that second step up as well. So now we've turned $6,000 into $80,000. And when I discovered this, that by the way, that was my job figuring out the financial model. So I was the first one to see this. I was like, excuse my French, but holy shit. Why hasn't someone seen this? Why isn't somebody else doing this? This is such an obvious model. And I don't have an explanation for it. I guess no one ever asked the question and went down the road. You have questions?
Well, obviously, building a 16-story massive steps of all your process going to cost a heck of a lot. How many years, once you get it going, will that be paid off?
Yeah, that's a great question. I haven't looked on the return on investment. We'll have to do that, but I haven't done that yet. So a couple things to give you some markers here to compare with. So the company we work with, the company is called We Swiss, name, but that's the name of the company in Switzerland. So another factor is, and it's reflected. Yeah, I'll just go through my bottom line. So the guy that we work with, his name's Jochen. So Jochen said one time, we're on a phone call, and he said, it costs us, 1/10 the cost to build one of our facilities compared to a smelter. So that means our capital expense is 1/10 that of a smelter. Well, that's pretty good. And then the next thing he said, oh yeah, and your operating costs, they're 1/6, 1/6 operating, 1/10 capital. Why isn't someone building these things? Well, it turns out they are, just not in the United States. So this company's got 17 of these plants running around the world in every other country but the United States. Well, not the other country, but in many other countries, but not the United States. He's excited working with us because he sees this as an entry into the United States, the market of its equipment. So he's very helpful at this point. Great question. Thank you. So, okay, help.
Just gonna aim it at
Where are you hitting that thing? Oh, it's down there?
Yeah.
Okay. So, how are we doing for time here? I'm probably talking on too long. Okay, I usually talk too long. So this is a kind of a summary of that previous slide. It shows, the discarded e-waste goes into collection. That's the IRT. It gets shred. IRT does that. The bottom path is all the complexity in transit that goes on in the black. And we're replacing all those things with bringing it in our building, and it goes out, replaces all that movement down below. And we're capturing all the same values they are at lower cost, operating costs. This is like a home run. Okay, let's see if I can. Oh gosh.
Yeah, you got it.
Okay, so who we are. Oh, I'm going to give you something. You can pass these around. On the back of it, these are some business cards. And on the back is our website. So if you want to go to our website and learn more details about what we're doing, and you're welcome to do so. So who we are. So I'm going to read it because so Reclaiming Critical Metals is our name. And we're a clean tech, metals refiner. We're a refiner. We're replacing smelting. And we're reclaiming critical metals from e-waste using environmentally safe state-of-the-art technologies. What it doesn't mention there is we're also catching a broader range of elements. As I mentioned, the smelters are collecting generally 6. We're collecting dozens of different elements. Now, a lot of them, frankly, aren't worth a lot, but we're going to collect them, process them, and sell them because they are worth something. And they're definitely necessary for our recirculating electronics economy. So we don't use smelting, we don't use toxic chemicals, we don't have acids, we don't have harmful emissions. For heaven's sakes, we're not going to have emissions because we need that dust because that's where all the value is. And so we're highly motivated to not emit. We don't even have, you would think of pounding mills and so forth. We asked the question, is it noisy? They said, well, if you're around it, you're going to need earmuffs because you are doing physical work and grinding and all those sounds. But they said they've got these plants are in, I'll call them light industrial neighborhoods, and they never have any complaints from other businesses around them. So we want to do this in the Iron Range because that's where we're from. 4 of us have we live here because we like to live here. 2 of us were born here. I wasn't, but I like it here. And we think that this would provide the Iron Range a steady business that provides jobs on a steady basis all year long through any economy. And so you don't have the up and down of the mining industry, that we would have a much more stable market. And so we believe we can provide jobs and provide economic stability to the Iron Range to help stabilize our economy here. So as a whole, we couldn't be more people can work on it and know they're going to have a job there, for a long time.
You mentioned, was it 3,300 jobs? How many jobs did you say?
So when we do 1 shift, 1 line, that'll be about 25 jobs. We expect to have 3 shifts, and so that'd be roughly 75 jobs. And we think, we're looking down the road that once we have that 1 line in, this is highly scalable, easy to scale, so we can add as many lines as we can put find product, the source of them. So our upside limit is actually the shredded to the circuit boards. And the good news is, of course, there's a lot of it right now that's available. And because the economics are so strongly tilted in our favor, we feel very confident we can outcompete anybody that's in the business in the United States currently, because they're into the old economic model.
What area flows through St. Cloud? It's not just Minnesota, or is it?
That's primarily Minnesota. So we're going to need material from more than just St. Cloud. This printed circuit board material is not unlimited. The 2 things: we need to get the law passed so that we collect 100% of it. That would help a lot. In the interim, right now, we would consume all of the material that IRT and St. Cloud has. Plus, we need everything that they've got in Wisconsin. There's a company in Wisconsin called Dynamic Solutions, I think it is, there in Alaska near La Crosse. And we would be getting the balance of what we need from them. And then there's a couple other collectors in Minnesota that we would probably pick up their output too as well. So we're going to be competing with the smelting companies because we're going to take the product that we send overseas and we're going to keep it here. You got a question?
There's about 25 data centers in Minnesota. Do you know where they send their garbage every 5 years when they cycle them out?
I do not. That they've never come up in the conversations. My guess is that they'll never get returned through here in Minnesota. My guess is they have somewhere else.
Yeah.
What is the Republican objection to jobs?
They didn't think of it. I don't know. They just want to vote no, I guess. I mean, it's the speaker that she just doesn't. I mean, we try to lobby her, and
It's the mining interests.
we're not competing with mining. The miners can keep mining. We need theirs too.
Yeah. In most respects, this is mining. It's not
Yeah,
dirt in the ground.
yeah, that's right, we're doing, mining of these waste stream.
Yeah.
So, I mean, we do not advocate mining, we do not advocate not mining. They're just overdoing whatever they need to do, and we need to have them continue the mining, I just hope they do it responsibly, but, we're not negatively impacted, as Rupali's studies shows, we need it all.
What's the transportation stream? Is it all trucking?
So right now, it's trucked, it's railed, it's put on container ships and goes to Japan or Korea or in Belgium, some over in Europe oddly. Interesting, Sudbury doesn't take any, and I don't know why, because it's smelled everything else there, but.
Who doesn't? Oh,
Sudbury, yeah.
But in the new system, will it be trucks and trains then?
Well, we expect it'll, we would be, for our first line, for one shift a day, we need 40,000 pounds a day. And so it turns out that's one truck trailer. So we would take one truck trailer a day until we get to two shifts, and we take two truck trailers. And so oddly, if you're going, I can't remember the exact number, but I'm gonna say around 15 or 20 truckloads. If you're doing less than 15 or 20 truckloads a day, you're better off trucking. At 20 or so more than that, then rail starts to become a factor, but then there's also distance. So for rail from St. Cloud to us, at the quantity we have, no way, it makes no sense. And even at high for us volumes, we probably still would not be going rail anywhere in Minnesota because of the distances too short. Yeah,
Have you been to Switzerland to see any of these RCM processing setup, running and working the way they do?
so you can see more online. There's a company called EnviroServe that's located in Dubai, and they're using this equipment there. It's one of the 16 in the world. So it's called EnviroServe, and you can go look at it. They're actually subsidized by the Dubai government. But they're an impressive, I wish we could simulate that. They have a much broader service. They're doing, for example, they're recycling, like your air conditioning unit. They can take the air out of it, coolants, they take coolants out of different things, and they're recycling a whole broad range of items that we aren't even looking at. But anyway, EnviroServe in Dubai is using this equipment right now.
There's something to be said for being on site and having a chance to talk with people.
Yeah.
Face to face, to learn things that you don't learn online.
Agree with you 100%. When we get right now, the company's doing an engineering study for us. And when that gets completed, that we're in phase one, we'll go to phase two, and then we'll have site visits. Yeah. We want to make sure that we know what we've got from an economics model, and all of the numbers work out before we start spending more money that we don't have right now. But definitely agree that we're going to be working with the engineers from both Swiss and doing site visits with companies that are using this.
When are you hoping to go live?
Well, good luck with that. So we see this as three phases. We're in phase one, which is getting the engineering study done. But right now, we're taking money from angel investors, and these are people that we know. We're telling them you've got at least a 90% chance you're going to lose everything you're investing with us. And because that's what we're using, something that's called a SAFE agreement. It's security agreement for something. Anyway, it's a certain type of financial document. You give us money, we give you a document that says if we're successful, then you get a portion of the investment's return. On the other hand, if it goes nowhere, you get nothing back. So it's good luck, and we better be successful. They don't get any value back. So anyway, they have funded our phase one, so we're able to do the engineering study. And then the second phase will be to get enough capital. And the question is, how much does this facility like this cost? It's around $15 million.
15?
15.
15.
15. Yeah. And if you go online and look at what a smelter costs, they're sometimes measured close to $1 billion to build some of these smelters. Now, those smelters I'm referring to are, massive. But anyway, So about $15 million will buy a plant with a single line.
Kind of interested in, if your technology will be able to develop farther and open up new sources. I remember reading something about, one of the solutions to mining operation tailing piles is there's so much material, lots.
So thank you for that. So the biomimicry I mentioned before, that little plant that it somehow knows how to do it, you can take that to a tailings pond, like on one of the mining ponds, toss it in, and it doesn't even have to be alive, it can just be dead of this plant. You can toss it into a tailing pond and it'll extract the chemicals. And
So
so,
there's a possibility that you could recover material from those.
yeah, in fact, we're thinking about that as a second business, that we would just go around and remining the tailing ponds. Yeah,
Can you protect your patents?
Well, yeah, we'll have Barb not post that part.
so try to finish up here. So real quickly, I think the summary is that we dramatically reduced the cost of refining critical metals. We dramatically lowered the environmental footprint for refining. We dramatically shortened the time from e-waste collection to the sale of refined metals. And one of the reasons all these collectors are excited right now, they're waiting 90 days, 120 days to get paid. We can turn it around in a week or two. And so they're like, that's time value of money. They're pretty excited. So we can offer them more, we think, and we can turn it around and pay them quicker. So they're really helpful. They want us to be successful. It's easily scalable. This is remarkably easy to scale. Lower capital, I mentioned that earlier, lower operating expense, dramatically lower transportation costs, 700 miles by truck and rather than sending it halfway around the world. We were planning on having a unionized local workforce, clean environmentally. The supplier of the equipment's got a sound record of installations around the world. And we've got the management team. You know, we're not like clones of each other. We're a very different group.
Now, the 5% that the current process is not able to deal with, would you be able to take that, or is that just?
That's what the biomimicry is going to do, is go after that last 3%.
But I mean, for other people that are doing this in smelters or whatever, is there anything that they're not able to finish the processing of that you would?
No, their process does take care of that last 3%. That's part
They
of it.
basically waste.
Yeah,
Yeah,
it
okay.
is pretty tremendous amount of waste and high, fuel costs.
Whatever they don't burn as pollution.
No. So we have an e-waste collection bill, and we've been running it for, like I mentioned, it's the 4th year now. We've been trying to get it through. And Senator Houschild supports it. He's voted for it in the Senate every time. He actually talks to us about it, and he sees this as a way to bring stable jobs to his district, so he's very supportive. Mr. Scrava is whoever the last lobbyist to talk to him is kind of the way he tends to vote. So most of the time he votes against it. So for example, the lobbying, when we get the bill coming before the committees in the House and the Senate, Apple and Best Buy bring in hundreds of consultants from the West Coast primarily to lobby our senators and House representatives. And so there's a heavy pressure by actually two companies, mostly Apple and Best Buy. They probably constitute only
What's their
5%.
objection?
The bill, if it passes, it will collect a manufacturer fee to fund recycling, especially where we live, where the counties don't have money for e-waste collection and recycling.
Right, so
The urban counties have more money already, but we need the money out here.
yeah, and so right now it's called producer responsibility, and the 4 items I mentioned to you back when the original law was passed, which was like 2017 or something like that. Or I can't remember. I said
Yeah.
the original law identified these 4 items, and producer responsibility, like Best Buy is already paying for producer responsibility costs on those 4 items. That would be extended to a broader set of products, and that. And anybody selling those products in Minnesota would be responsible to provide a a payment that is intended to take care of end of life. You know, they sell into the state and then they walk away. We're not responsible for the waste that we create. But we say, yes, you are. You need to factor that into your costs and pay for the recovery. So that money would then go to the counties and other collectors, and then they would use it to properly separate and handle. The counties are like, oh yeah, this would be awesome, because they want to get it out of their dumps. They don't want to dump it. It's dangerous for many reasons. Right now, we as taxpayers are subsidizing Best Buy. Should we be doing that? I don't think we should. So we're very much in support of the Best Buy taking care of that end of life. Right now, us taxpayers are taking care of the end of life. That's not right. That's my opinion.
I know your focus is on circuit boards, but do you think this technology could I hook a solar panel into one of those hammer mills and
Well,
instead of
there's-
plastic, you have glass as the
So the quick answer is not so good. It turns out that there's remarkably little critical metals in solar panels. Yeah, so that was a bad choice for your example.
Okay.
But I guess I don't want to try to answer that because I don't know the right answer.
Okay.
We've looked at a few things and everything that we've looked at didn't turn out to be suitable for one reason or another. Printed circuit boards are just ideal for this for mechanical separation. And so
I'm just
far,
amazed that you're actually able to separate like gold from lead by just pounding it.
and so a lot of this is done by weight differentials. You know, if I have
Okay.
material, you put them in like a centrifuge, think of it
Yeah.
that way. The heavy stuff's gonna go to the outside, the fluff goes to the middle. So there's things like that. It goes through all kinds of wind, like wind to blow the
Yeah,
light
yeah.
stuff away and the compression, but you do get down to that 3% where you can't separate it anymore. And unfortunately, that's where a lot of the value ends up is that last 3%. If that were plastics, we would just like give it away. That's the most valuable stuff, so that we have to process it. And we need a good solution for it. That's where the biometric comes in.
Would there be any attempt to harvest what's already in the ground? I mean, like jumps are filled with all of the stuff and nobody's doing anything about it.
No, I'm sorry, could you repeat?
Go to the dump.
Go to the.
Yeah, the
Oh,
dumps are gold mines of this stuff. For
Mhm.
years, everybody's been dumping it in the dumps. Is there any attempt to go after the dumps?
Not at this point. I mean, that's an obvious potential source. I don't know what the challenges are with that, though. I could speculate, but I don't know. Sure. It's a lot of value, $3 billion worth, and 75% of it's going into the ditch, into the dump.
So what's the best thing for us to do our e-waste right now? Take it to St. Cloud, or what can we do?
So your local, being located in Ely, you have to find the closest collector. And I don't know of any collectors, like in Virginia, we have that event every year and people keep their stuff, and then every year they come to that collection event we have in Virginia. If you could organize, you know, the Tower, Ely area and have an event every year and collect, then if you do that, if you have a collection, then we work with a company called Global Environmental Solutions, I think it's the name, GES, so I go by. They come when we have a collection. They're happy to come because they have a concentrated short period of time. They bring a semi-trailer, a couple trucks, and they set up little collection stations, and people bring in their stuff. Most of the stuff that comes in is free. You can just drop it off. Some like a Trinitron TV, they're expensive and they're a lot of waste material in them. So for GES, they're not worth anything, so they'll charge you for that. But the responsible thing to do is, you know, like every year my wife and I, we collect all kinds of stuff in the house and never seem to run out, and we always have stuff to bring to the collection event. But that's the only thing I can think of right now, because you don't have a collector up here that I'm aware of.
Couldn't hardly be a collector to take it to Virginia, if that's where it's going. Anyway,
I mean, I think
and, you know, an event,
I think we should do an event like he's talking about. I've gone to the one in Mountain Iron. It was a
Yeah.
lot of fun.
Yeah.
And Ball Lake Township is an awesome township. We could host it. So it
It's
would be
not
the-
high tech.
It would be the longest that company.
You had those
Yeah,
in the past.
in Ely or
Ely,
where was
in Ely,
it? Okay, yeah.
The key thing is to make sure you have a, arrangement like GES, and they're very, I don't know why, but they really want us to be successful. They really want to handle material in the right way. And oh, by the way, they do make money. It's a business for them, so they can't do it without working with, an organization or a community to make it work. Because it's all about transportation costs and density. So when they travel, how far you are from the Twin Cities here, but 350 miles, something like that. They need to get enough material on that trip to pay for the gas and the labor.
But all of their stuff goes in that first stream, it goes overseas somewhere.
So where's GES selling? So they probably Minneapolis. I don't know for sure, but they probably do sell it they could sell it either on Alaska or St. Cloud. Those would be logical places for them to sell it to. Because he's a lot of collectors like IRT is a collector, but GES is a collector almost. What differentiates him from St. Cloud is that he collects, GES collects, but he doesn't shred. He sells unshredded boards to companies like IRT who will do the shredding for him. So he's kind of a quasi collector, yeah. He does more of the front end. His big thing is he works with businesses primarily in the Twin Cities. Almost all the material he collects, like 3M will go to him and say, I got, 1,000 laptops to give you. They're all identical. How much you give me for them? And then, he sits down and says how much he estimates how much the value of everything that's in them. He gives them a price and he loads them up and then sells them to IRT. He doesn't process them himself, but he's really good at it, getting large quantities of these things and selling them at good margins. If you can get the material, you can make a good living. I mean, this guy makes a lot of money on this stuff. There's a lot of money. There's $3 billion in this stuff. There's a lot of money to go around to a lot of organizations. And I see we're actually over here.
Oh, yeah.
So
Barb, do you have any questions?
Yeah, I think we're just about at time we should quit. Thank Keith for opening up a whole new area for us to understand what's going on. And I would recommend to everybody look at Keith's website because it is very comprehensive. And if you're a little bit on the nerdish side, you will find everything you want to know right there.